Hello and welcome. In this video, we're going to be practicing some of the more challenging integration by parts problems. So let's get right into it. Let's say we have a question that tells us to integrate the ln squared of x with respect to dx. Ln squared of x, this is exactly equal to ln of x all to the power of 2. It's the same as ln squared of x. It's written that way. Okay, so let's see what we can do over here. So now we know that I need to choose something as my u, and this u I know that I will need to differentiate it to get du, and I will need to choose something as my dv, and I know that this dv I'm going to integrate it. So it's always wise to choose something that is easily differentiated when you're choosing u, and something that's easily integrated to get v when you're choosing dv. So over here, what I'm going to do is I'm going to choose ln squared of x as u, and dv I'm going to choose as 1, because this is the same as ln squared of x multiply 1. So when I try to differentiate ln squared of x, this is going to equal, using the chain rule, which I did a video on, so please click the top right hand corner if you want to check it out. So it's going to be 2 times ln of x, and then we reduce the power from 2 by 1, so it becomes power 1, and then we multiply by the differentiation of what's inside. So this is ln x all squared, so we multiply the 2 to the coefficient, so it becomes 2 ln x, and then we reduce the power by 1, and then we multiply by the differentiation of what's inside. What's inside is ln x, and I know that the differentiation of ln x is basically 1 over x, so I'm going to multiply by 1 over x. This is du by dx, so if I want only du, I'm going to multiply dx to the other side, so it's going to become dx over here. Okay, for dv, it's super simple. If I want to integrate dv dx, okay, so it's 1 dx, so it's equal to basically x. Now, using my integration by parts formula, let's write it down. It tells me that the integration of u dv equals uv minus the integration of v du, and we derived how we reached to this equation in the previous video. It's super helpful. I'll leave a link to it on the top right hand corner. Please go check it out. So let's using this equation. So this is equal to uv, so my u is ln squared x, my v is x, so multiplying them together is going to be x times ln squared of x minus the integration of v du. So v is x, I'm multiplying du, which is 2 times 1 over x is basically 2 over x, multiplying ln of x dx. Okay, so this is equal to, this part I'm gonna leave exactly the same, and I'm going to see that I can cancel this x with this x over here. I can bring this 2 outside of the integral, so it's going to become minus 2 integration of ln of x dx. Okay, so what is the integration of ln of x? So let's take this again and see how we can solve it. So let's integrate by parts again. Okay, let's choose our u as something that's easily differentiated. In this case, I'm going to choose it as ln of x. The differentiation of that is going to be 1 over x, and I multiply the dx to the other side. My dv, again, I'm going to choose, because this is the same as 1 multiplying ln x, so I'm going to choose my dv as 1. That will give me a v value of x. Again, I will use the same formula, but I will rewrite this part. So x ln squared of x minus 2 into the integration of ln of x, which is going to be integrated by parts again. So this is equal to uv. So u times v is x times ln of x minus integration of v du. So v is x, du is 1 over x dx. So over here, as you can see, we can move forward super easily. I'm gonna rewrite this again. minus 2. I'm going to distribute the 2, so it's going to be minus 2x ln of x. And then I can see that this x and this x will cancel. Minus 2 times minus 1 is basically plus 2 integration of 1 dx. So this is simply minus 2x ln of x plus integration of 1x is basically x. So this is going to be 2x, and I don't forget my constant of integration, and this is going to be my answer for this question. Let's take another example. Let's say we have the integration of ln of x over square root of x dx. So I can rewrite this as integration of square root of x. I can rewrite it as x power half over here. And I know if it's power half on the denominator, if I want to put it in the denominator, in the numerator, is going to be negative half. So this is going to be x to the power of negative half, because I know that a power m is equal to 1 over a power negative m. So if I want to switch something from the numerator to the denominator or vice versa, I just multiply its power by a negative. So this part over here is going to be x power negative half times ln of x dx. Again, which is easier to differentiate from these two, or which is easier to integrate? Okay, x power negative half is easier to integrate, okay, and ln x is complicated and we don't want to go through that, so I'll smartly use my u as ln of x, and that will give my du as 1 over x dx. Okay, my dv I'm going to choose as x power negative half, so that gives my v. Integrating using the power rule is super simple. You just add 1 to the power, so x power negative half plus 1, that is half, and then you divide by the new power. So dividing half is the same as multiplying 2 over 1 or multiplying 2, so v is 2x power half. Again, if we want to use our formula, let's try and copy it to have it in front of us. Okay, so if we want to use the integration by parts formula, what we can do is we can make it smaller, and yeah, so this basically is going to equal to uv. Okay, so my u is ln x, my v is 2x power half times my u, which is ln of x, minus integration of v du. Okay, so v is 2x power half times du, which is 1 over x dx. Okay, so I can rewrite this. I'm going to change this x power half to 2 root x just because it looks better. Ln of x minus, okay, I'm going to bring this 2 outside, so it's going to be minus 2 integration of, this is basically x power half over x. And I know when I have an a power m over a power n, this is basically equal to a power m minus n. So I can rewrite this whole thing, okay? This is also dx, so I can rewrite this fraction as x to the power of half minus 1. Correct? Because it was x power half over x, so it's half minus 1. The power here is 1. Okay, and I know that half minus 1 is nothing but negative half, so I can change this to negative 1 over 2, and then I can perform my integration over here using the integration power rule. So I will rewrite this part, minus 2 into, so x power negative half, integrating that, it's super simple. We add 1 to the power, so negative half plus 1, that is half, and then dividing by the new power, so dividing half is the same as multiplying 2, and then we don't forget the constant of integration. So this is going to equal 2 root x ln x minus 2 times 2 is 4. X power half, I'm going to write it as root x plus c, and this is going to be my answer for this question. Let's take a look at another example. which is interesting. Let's say we want to integrate by parts cosine squared of x dx. Okay, so over here, what I can do is, I know that could be rewritten as cosine of x times cosine of x dx. And from here, I can choose something that's super interesting. I'm gonna choose my u as cosine x. That makes my du equal to, differentiation of cosine is negative sine x, then we multiply by dx. My dv, I'm gonna choose also as cosine x, so it's going to equal cosine of x. So my v is the integration of that, so it's gonna be sine of x. Okay, so moving from here, using our integration by parts formula, we can say that the integration of this is going to be equal to uv, so it's going to be cosine of x times sine of x, minus the integration of v du. So v is sine x times negative sine x, that is negative sine squared of x dx. Okay, so I can say that this negative and this negative will cancel out, so I will have something that looks like this. So moving on from here, I can see that I need to integrate sine squared of x, and I know that using trigonometric identities, which I have a full video which is super useful, that helps you in grouping identities and how to use them. I'll leave a link to it on the top right hand corner, feel free to check it out. I know that cosine squared of x plus sine squared of x equals to 1, so I can replace sine squared of x. Moving this to the other side is going to become 1 minus cosine squared of x. So I can rewrite this whole thing as, let's erase this part, as cosine of x sine x plus integration of, instead of sine squared of x, I'm gonna write 1 minus cosine squared of x multiplying dx. And then now what I can do is I can rewrite this as plus integration. I can split this integration, so I will integrate the 1 dx alone, and adding to that integration of negative cosine squared x dx alone. And I know that this whole thing is equal to the integration of the main question, or the original question. So this is equal to integration of cosine squared of x dx. So I know from here that this part is very similar to this part. So if I move this whole term to the other side, it's going to become plus integration of cosine squared of x. It's going to add up to this one, and they're going to be it's going to be 2 integration of cosine squared x dx. So cosine x plus sine x plus, what's the integration of 1 dx? That's simply x, and then I have a plus c over here, equal to integration, when this moves to the other side, is going to become positive, cosine squared of x dx plus integration of cosine squared of x dx. And combining those two together, I can say that they are basically 2 cosine squared of x dx. So if I want to get the answer for integration of cosine squared dx, I'm going to divide by 2, divide by 2. So my answer to the question, which is integration of cosine squared x dx, is equal to this whole thing, which is cosine x sine of x. This is not plus, this is, they're multiplied. Cosine x sine x plus c over 2. And this is going to be my final answer. Let's take a look at another super interesting example. Let's say we have the integration of x cubed over x squared plus 2 all squared with respect to dx. So this is super interesting because I will need to choose a u and a dv value. The u value, if you think, okay, let me choose my u value as x cubed, du is simply going to be 3x squared. That leaves the dv value as the 1 over x squared plus 2 all squared. However, to integrate this is super difficult. But using the u substitution video or the u substitution technique, which I have a video on that I'm going to leave in the top right hand corner, I know that if I had something that is an x over here, this is dx, okay, I can u substitute this part, okay, because the derivative of this part is going to be something with x, going to be 2x, so I can cancel it with this x, and I know that I can basically integrate this easily if only there was an x over here. But why don't I do that? Let's see how we can do that. Let's rewrite this integration into, I'll split this x cubed into x squared times x, this is basically x cubed, over x squared plus 2 all squared. And now I'm gonna choose my u as x squared. So this part over here is my u, okay? And this whole part over here is going to be my dv. Why? Because I know that the integration of this part could be done using u substitution. This is with respect to dx. So let's choose our dv as x over x squared plus 2 all squared dx. And let's try to get v. First of all, du from here is the differentiation of x squared. This is super simply 2x. Then I'm multiplying by dx both sides. Over here, to get v, I will need to do the integration of this part. So I will need to integrate x over x squared plus 2 squared dx in order to get my v. So let's see how we can do that on the side. So over here, I straight away notice that the differentiation of this part is 2x. And I have an x here, which I can cancel it out using the u substitution. So let's see how we can do that. Let's u substitute. Let's say that u is x squared plus 2. That gives du as 2x. So du by dx is 2x. So multiplying dx both sides is going to be 2x dx. And that gives a dx value of du over 2x. I'm basically dividing 2x both sides. So let's now substitute everything. Let's now substitute this dx with this expression, and let's substitute this with u. Okay, so we will have integration of x, which is the numerator, over this whole part is now u, and it's raised to the power of 2. And then instead of dx, I'm going to multiply by du over 2x. And I straight away see that this x will cancel with this x, and I will have the integration of, I will take this 1 over 2 outside. So it's going to be 1 over 2 integration of 1 over u squared du. And this is super simple. I can rewrite it as integration of u power negative 2 du, and I can use the power rule super simply. I'm gonna have a half, I'm gonna add 1 to the power, negative 2 plus 1 is negative 1, and then I'm gonna divide by the new power. Dividing by negative 1 is basically simply this. So my answer is negative half u power negative 1. Okay, now let's substitute u back with the original substitution, which is x squared plus 2. So it's gonna be negative half of x squared plus 2 power negative 1, which is equal to negative 1 over 2 times x squared plus 2, because this negative 1 will make this whole parentheses go down to the denominator. So basically this is my v. So let's copy this over here, knowing that this value over here is going to be my v value, and let's put it over here. So my v value is going to equal this whole thing. Okay, let me just neaten up everything. Okay, so now getting back to our integration by parts, we know that this is using the integration formula. The integration by parts formula is equal to uv. So u is x squared multiplying v, which is negative 1 over 2 x squared plus 2. And then minus the integration of v du. So v is negative 1 over 2 times x squared plus 2 multiplying du, which is basically 2x dx. Okay, and let's try and simplify a little bit over here. So this is going to be negative x squared over 2 times x squared plus 2 minus, okay, this minus and this minus are going to be pluses, so it's going to be plus integration of this 2 is going to cancel with this 2. I'm going to have an x over x squared plus 2 dx, and I can see that this part over here is easily integrated again using u substitution. Why do I say that? Because I know that if I choose this as my u, my differentiation is going to be 2x, and I have an x here which I can cancel with it. So let's see how is that done. So again, let's u substitute. U is going to equal x squared plus 2. So du by dx is 2x. So dx is du over 2x. Let's substitute everything. So this is going to be negative x squared over 2 times x squared plus 2 plus the integration of this is x, this over here is going to be u, and instead of dx, I'm going to replace in du over 2x, and straight away I can see that this x will cancel with this x. I can bring this 2 outside, so this is basically, I can bring this 2 over here. So this is basically the integration of, let's rewrite this part again, squared plus 2 plus 1 over 2 integration of 1 over u du, and instead of 1 over u, I can rewrite it as u to the power of negative 1, and I can perform my integration now. And I know that the integration of u power negative 1 is basically ln of u. So this is going to be negative x squared over 2 times x squared plus 2 plus half times ln of u plus c. So now to finalize our problem, we will substitute back u with x squared plus 2. So this, the final answer is going to be negative x squared over 2 multiply x squared plus 2 plus half ln of x squared plus 2 plus c. And this over here is going to be my answer for this question. Let's take one more example. Let's say we have a question that goes like this. We need to integrate x times 2 to the power of x dx. Now, what do we do over here? The problem is that 2 power x is difficult to integrate and or differentiate in its form like this. Okay, so first of all, I will choose my u as x. I will try to choose my u as x, because if u is x, then the differentiation of that is super simple. It's just 1 dx, and I want to make my life as simple as possible. That leaves dv as 2 power x dx, this part over here. So to get v, I will need to again integrate this dv. Because going from dv to v, I need to integrate. So my v is going to equal the integration of 2 power x dx. Okay, how can we perform that integration? Let's rewrite it in a clever way. Let's say we have the integration of, and instead of 2 power x, we will write it as e to the power of ln of 2, all to the power of x. Okay, what did I do here? I know that e to the power of ln of anything like a is basically equal to a. because e and ln, they cancel each other out. So this is what I did. This green part over here is nothing but 2, because e to the power of ln of 2 is going to cancel and going to become 2. This 2 is raised to the power of x, so this green part, I raised it to the power of x. This is all what I've done right here. So now I know that if I have something raised to something else, okay, I can distribute this and I can multiply it over here. So this is going to be, this is dx by the way. So this is going to be integration of e to the power of x ln of 2. So I did nothing but multiplying this x over here, dx, okay? So from here, I can use u substitution to solve. So what I'm going to do is I'm going to substitute u as x ln of 2. So du by dx, which is the differentiation of that, is simply ln of 2. Because ln of 2 is nothing but a number. It's just a constant. It's just like differentiating x multiply 2. It's basically 2, which is like 2x. It's basically 2. So ln 2 is just a number. So the differentiation of x ln 2 is basically ln of 2. So my dx is going to equal du over ln of 2. So let's distribute and substitute everything. So integration of e, instead of x ln 2 is going to be u, and instead of dx it's going to be du over ln of 2. So this is nothing but 1 over ln of 2 integration of e u du, and we all know that the integration of e to the power of u du is nothing but e to the power of u. This is going to equal 1 over ln 2 e to the power of u, and now I can substitute back my u with original x ln of 2. So I'm gonna erase this u, I'm gonna put in x ln of 2. So this is basically the integration of this part over here, and you can think about it as integrating e to the power of this thing and then dividing by the differential of this over. Is just like the reverse chain rule, okay? So you end up with this, which is my v. So let's again copy this part, knowing that this is our v now. Let's copy it and put it in our integration by parts over here. So v is equal to this thing over here. So this is v. So let's use our integration by parts formula. So I know that this is equal to uv. So x, which is u, multiply this whole thing. So multiply e to the power of x ln of 2 over ln of 2 minus the integration of v du. So the integration of this whole thing, multiply 1, which is basically the integration of e to the power of x ln of 2 over ln of 2 dx. So what I'm gonna do is I'm going to rewrite this whole thing over ln of 2, and I'm gonna take this 1 over ln 2 outside. Ln 2 integration of e to the power x ln of 2 dx, and we can see that this integration is just like the integration that we just performed over here. So we already have the answer to this integration of e power x ln 2, integration of e power x ln 2. It gave me an answer of this thing over here, which is this part. This is the answer. Okay, so I can rewrite this whole thing as x e power x ln of 2 over ln of 2 minus 1 over ln of 2 times the integration of this, which is basically e power x ln 2 over ln 2. So e power x ln 2 over ln of 2 plus the constant of integration. So I can multiply these two together just to simplify everything. So let's write the final answer as e power x ln of 2 over ln of 2 minus e to the x ln of 2 over ln of 2 squared. So this is basically the final answer. And what I can do to simplify this even more, e to the power of x ln of 2, I can do the opposite of what I did in the first part. I know that this could be written as e to the power of ln 2 all to the power of x, and I know that this part over here is nothing but 2 all to the power of x, so I can substitute this thing and this thing with basically 2 to the power of x, so my answer is going to equal x times 2 to the power of x over ln 2 minus 2 to the power of x over ln squared of 2. I can't forget my constant of integration, and this is how to solve this question. So basically, integration by parts, the best advice I can say is to try and approach and solve as much questions and as much different ideas as you can, so you know the tips and tricks for these kind of questions. Anyways, thank you so much for watching. I hope this video was helpful. Please don't forget to like, share, and subscribe. If you have any question or topic you'd like me to discuss, please leave it in a comment down below and I'll make sure to read it. Thank you so much for watching. Have a nice day.